So I'd now like to introduce our speaker. François-Nicolas is a geographer with special interest in spatial hydrology, forest ecology, and geomatics. In 2013, he arrived in Canada from France to start his PhD in forest management at the University of Alberta. His PhD thesis focused on wildfire risks to water security, a topic that he continued to research during his postdoc with Global Water Futures. During his 2 years in the Canadian Forest Service, he worked as a wildfire research scientist and analyzing post-fire risk to drinking water supply. Currently, François-Nicolas is a habitat analyst for the Pacific Salmon Foundation, and Francois lives in Edmonton on Treaty 6 territory and within the Métis Homelands and Métis Nation of Alberta Region 4. So with that, I will stop sharing and I'll hand it over to Francois for his presentation.
Okay. Thank you very much for having me tonight. And thank you very much, Camille, for the introduction. Thank you very much to Living Lakes Canada for the offer to present my work. Yeah, like I added my email address. If at the end of the talk, you want to reach out to me with more questions or for asking for some resources, and I'll be happy to share some resources with you down the road. So yes, let's today talk about wildfires and flow and how wildfires, modify watersheds, the way they work, and eventually impact our water supply, or more generally speaking, our water security. And when we talk about water security, a very easy way to think about water security is like essentially when in the morning you go to your kitchen and you open the tap, you have clean drinking water getting out of it. And in the afternoon, perhaps you want to go to the river and, like bathe in the river, do some fishing as well, because the river is clean, full of fish. This is also a part of what we call water security as well. So in Canada, we're pretty lucky with that. But as we will see, wildfires can really create some pretty serious challenges when it comes to water security. Just a little bit about me. Thank you very much, Camille, for the introduction. Just wanted to, I guess, give a few more details here. I was trained a risk geographer, so my training is in risk and disaster risk management, and I started to work on this nexus of wildfires, forest, and water supply. Pretty much 20 years ago during my undergrad. But I've done a whole lot of different things in this 20-year period, and a very common, I guess, like career path for geographers to do some GIS remote sensing. I did a lot of that as a technician, as a manager as well, always working in the world of natural resources management and forestry. And I've grown, I guess, like I can claim that I have become a data nerd. I really like to look for data. I really like to look at them. I really like to create them, and I'm very adamant about data quality and data openness. I think like open access to data, especially scientific data, is one of the best way to move forward with like knowing our ecosystems and protecting them. So what you guys do during the Lake Blitz is like really great. Keep on going. I'm new Canadian. I've been here for 11 years, but like only Canadian for like 9 months or so I'm pretty happy about that. And as Camille said, like I've been like since 2023 habitat analyst for the Pacific Salmon Foundation. My main project right now is building a database of stream flow and stream temperature for the Pacific region, so British Columbia and the Yukon. And it will be available in a couple of years from now on the Pacific Salmon Explorer, which is our sort of like flagship platform. But in the meantime, it's open. You can go and you can go see what the Pacific Salmon Foundation has been creating. Data is open. You have a lot of documentation as well. So if you want to know more about salmon, especially in British Columbia, pretty soon the Yukon as well, just go there, take a peek, and just browse the website a little bit. All right, so let's get into the meat of the topic tonight. I think before we start talking about wildfires, I think it's important to understand how forests especially contribute to water security. Here in Canada, we're very lucky. Again, we have a lot of forests, we have clean water, and there is a large amount of evidence that forest is a large contributor to our water security. And obviously, I won't go into any like sort of like deep details, but it's necessary to understand how forests generally work in terms of in the water cycle. And forests essentially intercept part of the precipitation, then it's it's blocked, and then like a part of it is like re-emitted up to the atmosphere. But a fair amount of the precipitation is going to go down to reach the forest floor, and is going to either, like, usually not much, you won't have much runoff on the forest floor, but it's going to infiltrate and percolate and like start to go downhill. But a big part of it will be stored as well. So a forested watershed has fulfills those four functions. It acts as a shield, like, because you have like the vegetation, you have a forest floor. It protects the soil from erosion, from the impact of precipitation, and from water running off downhill. So there is the shield function. There is also the function of a sponge. You have, like, we always talk about the forest, people think about the trees, but actually the forest floor is perhaps as important as the trees, if not more, because there is all this organic matter, pretty deep soil that is able to absorb and store this water and allow it to percolate, so to go pretty far down in the soil profile and become groundwater essentially. And while this water is like being retained, being stored, forests like act as natural filters as well. Like, there is ample evidence showing that for those communities that draw their water from forested watersheds, that cleaning the water is like out of the sources, like much better quality, and like it's much cheaper to treat. So yeah, forests are great in this respect. And the fourth function is like it provides habitat for aquatic ecosystem, aquatic species. It provides food, it provides habitat, it regulates temperature, it regulates the amount of sediments reaching the river. So again, really important, those four functions for having healthy watersheds for us, and clean water and like healthy aquatic ecosystems. As I said, in Canada, we're very lucky. We have a whole lot of forests, mostly like what we call the boreal forests, covering like 75% of our landmass. It also harbors 70% of indigenous communities. So I was talking about water security, but for many indigenous communities, it's also a matter of food security. They really depend on the forest to provide a whole lot of things. And we all know, like in Canada, we also have a lot of water. Like, those two things like overlap: our forest, our water. As you can see in this in this photo up here, for instance, it's in Wood Buffalo National Park, in the Boreal Plains. Whole lot of water, whole lot of forest, and we have in Canada 20% of the world's water resources. Like, when I talk here in terms of storage, 20% of the global amount of water is stored in Canadian water body. But we have, depending on the estimates, up to 9% of the renewable water, global water resource. So when I talk renewable water resource, it means like on a yearly basis, essentially that's the amount of water that is running off the surface of continents. So essentially, over all the quantity of water that is running off Earth, like our continents, in Canada, we have almost 10% of it flowing through our land, which is, again, like quite great. A conservative estimate says that we have 800,000 lakes. We probably have more than 1 million, but it's very, very hard to know, because we have so many of them, and the landscape can change quite a bit during the course of a year. Of like just something that can be hard to estimate, like to give like a definitive number on. And 85% of our municipal water supply comes from surface water in Canada, so like rivers and lakes. And to give you a bit more, I guess, details about like this water supply, we like. And like the the combination between water supply and the forest cover here, this is a data set that I released last year. There is something unfortunate in Canada, is that we have a lot of water, but we don't really know where's the water, where our water supply comes from. So I sort of wanted to contribute to that by creating this data set of source watersheds. So all those watersheds you can see here, covering 45% of Canada, are those watersheds that provide municipal water, or for short, drinking water to Canadians. And as you can see here, that's a graph that goes with this data set, and that shows that that's all the catchments that are sort of classified by size. And you can see that there is the forest cover, the average forest cover for a lot of those, the percent forest cover, sorry, for all of those catchments is usually quite high. So again, this combination and this importance of the forest cover for our water supply in Canada, is shown here, in the forest cover of our national watersheds. And because we're talking about lakes as well, to create this data set here on the left, I essentially I went to all the provinces and I asked for their water licensing. So when you want to, any stakeholder in Canada, when they want to withdraw water from a water body, they need to apply for a license or for a permit. And so in Canada, it's over 3,000 licenses or permits to withdraw water from municipal water uses, or again, drinking water for short. And here, that's all the licenses, only for that, all the licenses that are used to withdraw water from lakes and reservoirs. So it represents 38% of all the water permits in Canada for drinking water supply, but it is 56%. It represents 56% of the total volume of water that is withdrawn for municipal water supply. So lakes and reservoirs provide most of the municipal water supply in Canada. The thing is that we have a lot of forests, obviously, and most of our forest is coniferous forests, so conifers burn very well. And obviously, as if anybody had forgotten, last year was definitely I would say a wake-up call, but I'm sure you were already aware that Canada can burn quite well. And as you can see here, that's from the data from the federal government, the National Fire Database, where you see that it's definitely a very widespread phenomenon. And actually, arguably, this is the most important ecological process within the Canadian forests. Over 55% of the ignition, so the fire that start naturally, it's most of the time started through by lightning, and only a very small proportion of those fires that start become those big fires, and usually further up north. But it's it's changing as well. The cost of firefighting, it's increasing every year, and the forecasts are not looking good at all. And here I'm only talking 1.5 billion on average per year is the cost of firefighting, but I'm not here even including other costs that are related to an actual disaster, like Fort McMurray. I think you guys remember there was $8 billion in just in insurance claims. So you also have to consider those things that are not insured, or even ecosystem services. Many of the benefits you gain from nature that don't necessarily have a monetary value. It's also a whole lot of losses that can be hard to quantify, but we're talking here billions of dollars, no problem. And the reality of our wildfire situation in Canada is we definitely see an upward trend in the number of evacuations. And unfortunately, most evacuations in Canada happen in Indigenous communities. Some Indigenous communities sometimes can be evacuated twice or even 3 times during one fire season because of a fire, usually not directly from the flames, but mostly because of the smoke. And it can be quite challenging because many of those nations don't have, or Indigenous communities don't have, a road to evacuate. So it has to happen by boat, or it has to be happen by air. And we can see this large map, of fires burning everywhere, and one might think that okay, it burns, it's pretty straightforward. There is only one way of interpreting that, but actually, it's not the case. The way Canada burns, it burns in a very, very, very many different ways. Just for the simple reason that our country is big, we have a lot of differences in vegetation, in soils, in topography, and a colleague of mine, Sandy Ernie, in 2019, published this paper showing she was able to classify the Canadian forest into 60 different what we call fire regime units. So a fire regime is like the historical pattern of fire activity in a given area. So when I say fire, like the pattern, I say like, fires, like the typical fire severity, the season during which a fire will burn, the size, the typical size of a fire, the dominant cause of ignition. And we were able to divide Canada. She was able to divide Canada within like 60 different units. It means like you have potentially 60 different ways a fire will burn in the country. And one can imagine, if you start to put that together with like impacts on water, you can imagine that those different fires are not going to impact the water the same way. So different fire regimes that are increasingly impacted by, obviously, by climate change, with like longer fire seasons, more like ignitions. It's hotter and drier, so you have like higher fire severity, higher fire intensity and then severity. But you also have historical fire management that have sort of like, that's part of the problem. I won't get into the details here, but just know it's part of what influences our current wildfire activity in Canada. We also have we've seen a big increase in the number of wildland, what we call wildland human interfaces. You probably heard of wildland urban interface, like the WUI. So essentially, those interfaces are throughout the country, all those areas where the wildlands get into contact with human activity. So it could be houses, it could be oil and gas, it could be a road, but those areas usually are preferential areas for ignitions, but also for incoming fires to burn. So they are essentially they can be in the path of a fire. And forest management as well, like the way we've been historically managing our forests in Canada, also like influences the way our forests burn. But again, I won't get into any details here. And because now it's time to switch to watershed response to wildfire. So those different fires, as I said, like Canada is very diverse, a lot of different ecosystems, a lot of different, I guess, like ecological areas, a lot of different fire regimes. So one might be like, hey, sorry, my kids were quite noisy. Sorry about that. Just like cut my thinking a little bit. So yeah, one might think like, okay, we have so many different types of fires, just like might be complicated to really have like even like one single response to wildfire when it comes to watershed and water resources. But it's possible. Now we have like I would say like enough science available to provide you with like what I would call a post-fire hydrology 101. Like sort of like the worst case scenario, and I really insist on that. What I'm going to talk about right now is like really the worst case scenario, because I don't want people to think that fire is bad and only bad. And when it comes to water and water ecosystems and water supply, fire can only do bad things. It's not the case. As I said, like fire is like probably the most important forest process, like in terms of like long-term health of our ecosystems. It's a necessary part of our Canadian forests, and arguably because it maintains the health of our forest ecosystems, it probably also impacts positively or negatively the health of our aquatic ecosystems as well. So just want people to think about it. Like I'm really going to try to talk about sort of worst case scenario, a watershed that is used by people. And so like in case of a fire, yes, we might have some impact that we will see as negative only. So yeah, in this case, high severity fire, let's imagine it has burned most of the watershed, if not all of the watershed. At a high severity, it means like there is hardly any vegetation left. There is no organic matter left on the ground. So you see the mineral soil. And all of those functions I was talking about earlier essentially disappear. You won't have the protection by the vegetation or the ground cover anymore. So you have like precipitation that can really hit the ground at like full velocity and just going, like to do this like accelerated weathering processes. It's just going to erode quite nicely and like quite dramatically possibly. And because you also have like these changes, like water is not retained. There is nothing, like to stop the vegetation, to slow it down. The sponge effect disappears as well because you don't have a sponge effect anymore. Like that's when, like, when the water is absorbed, that's when you have this filtering function that, like kicks in. And Again, here, because you don't have that anymore, you lose this water quality. I mean, this capacity to filter the water and have better quality downstream, better water quality downstream. And habitats will change as well. So all those like sheltering capacities from provided by forest, also going to disappear. Like, so it's illustrated here. You're going to have a lot of erosion, like high runoff, and you might end up having like this sort of like the small clear creek at the end of your yard might just turn into like this sort of like big ash slurry, and you can imagine that fish in this sort of ecosystem, like in this sort of situation, just essentially cannot breathe, and you might see some pretty severe fish die off after the first rain. So essentially, what a fire does, it changes the watershed conditions. So here it's just a few illustrations of what I was talking about. Here you see this patch, that's a high severity burn. You have no vegetation left, you have nothing left on the ground, just ashes. And here, that's another way of looking at it here. That pretty steep slope, no vegetation whatsoever. If you sort of look here, like the soil is not cohesive anymore. Like if you have, it's prime for erosion here. No, okay. Excuse me.
We anticipated a little visit, didn't we?
Sorry about that. That's the okay. Where was I? Okay, I was about to get to this third image here. So like something that might make even like erosion and changes to water quality way worse, like increased runoff, is linked to hydrophobicity or water repellency. So essentially, when you have vegetation that start to combust, it's going to release a number of like waxy elements that are going to precipitate on the soil surface or a little bit underneath the soil surface, and that is going to create this sort of like essentially a slide. So like when the water is going to reach that, instead of like again percolating, it's just going to slide downhill even faster. A way to visualize what the repellency is, like I'm sure everybody in the audience has tried to make yourself a hot cocoa, and like you put the cocoa powder, you start to put the milk, and it just won't mix. And and that's exactly, it won't mix until you warm up the milk, and that's exactly the same principle for soil hydrophobicity. It just like won't mix, and when that happens at the top of the soil surface, like here, you see like those droplets, they won't infiltrate, and once you start to have a whole lot of them, what they do is gravity, it's just to go downhill, and with them they get a whole lot of soil. So and because there is no vegetation cover anymore, you start to have a lot of sediment accumulation, as you can see in this picture here. It might even change, the path of the river. So again, like you can imagine easily how it changed the river functioning, and potentially the way that the aquatic ecosystems, how they might be impacted. And last point I will come back to is smoke. We are increasingly realizing how bad smoke can be, especially from like to lake ecosystems, especially, and like from a water supply standpoint. But from a general public health standpoint, smoke is pretty bad, but can be very bad for lake ecosystems and downstream water supply. So we know that burn severity, like I talk about a lot of things, but there are two main factors that will really contribute to post-fire impact to watershed functioning and to water resources and water supply. The first one is burn severity. Usually, like if you have like big fire like burns at a very high severity, so you have no fire, no vegetation left, that's one of the big drivers of post-fire response, and that can lead to potentially to water pollutions or changes to stream flow. And the second big factor is like post-fire rainstorm. We have examples of like big fires that were followed by minor precipitation or none at all, and you don't really see any sort of change. But when you see after a big fire, severe fire, you start to have like heavy rainstorm. This is when you start to see flash floods, debris flow, and you start to see this kind of like, I guess, like crazy sort of like watershed, like like changes to watershed processes. Here, this is in Montana. You have like one person in the middle of this gully in this burnt area. It's moving boulders, moving massive rocks. You can imagine the sort of damages that can create. A lot of here that's woody debris, like trees, essentially same thing. Like you can imagine how much it might change, the functioning of a river, and how much it might damage potentially infrastructure downstream. And here, this is an example, not woody debris, but just a debris flow, a lot of sediments, a lot of rocks as well. So huge sediment input here, and that can potentially damage like infrastructure and infrastructures as well. We have changes to snow accumulation, snow accumulation and snow melt patterns. Usually in the burnt area, you might have like more snow that will accumulate, but it's going to melt much earlier in the season as well and much faster. Obviously, changes to water quality. You have just more sediments, more ashes, and you see here, this is like the Cameron Falls in southern Alberta in Waterton National Park. Usually it's like crystal blue, but as you can see here, right after the Kino fire of 2017, you have like what we call the first flush, and essentially ash and sediments like make the water not very hospitable, I'm afraid. And one of the main results of wildfires as well is like wildfire act as essentially that's, I don't know, like a giant fertilizing process. You're going to have after a fire, we tend to see an increase in like those essential nutrients. So you're going to have carbon, phosphorus, nitrogen, potassium, a lot of like metals as well, like mercury. But like some of those very critical nutrients, like nitrogen and phosphorus, they're going to get into the water and they're going to boost productivity. So you're going to have just more biomass available within your lake or within your river, to a point where some people, worry that it can create algal blooms, especially harmful algal blooms. We don't have much evidence of that. It's definitely a concern. But anyways, those changes to watershed processes can lead to what we call wildfire watershed risks. And the term was coined like in 2013, trying to really put together those kind of concerns and be like, okay, how do wildfires that happen within a watershed can lead to some risks that are really detrimental to water supply, but also like to human life. So like, here you can select various illustrations, a mud flow. In 2018, the Montecito mudslide in Southern California led to the death of 23 people just after a fire, for instance. Definitely not something to underestimate. I talk about, like I'm sure some of you are anglers. Well, after a fire, you might see like just like pretty big fish die off, and like essentially like your favorite fishing spots essentially are not usable anymore. We also have increasing concerns regarding urban storm runoff. When we have like I talked about those interfaces, like some places like houses, structures that might burn, and quite often, when they burn, they might burn like close to a river, close to a lake, and like we really worry about like what the sort of pollutants that might end up in this storm runoff. We have a lot of plastic that burns. A lot of the combustion of plastic creates a lot of carcinogenic products. Again, this is a very new area of work for a lot of people in this field, but like findings so far are not very encouraging, I guess, or pretty worrisome, I should say. We have issues when it comes to reservoirs as well. Like this is a reservoir in southern California. It's filled with sediments and ash from an upstream burn, and dredging a reservoir can cost millions of dollars, which eventually is paid by taxpayers usually. So just something to keep in mind as well. Damages to infrastructures, and probably one of the main things, at least in Canada, that has really been pushing for the advances on this topic, scientific advances on this topic, is the worries about drinking water. We know that Fort McMurray is probably like the best example in Canada. I think if I remember well, since 2016 and the fire, it's about $10 million of extra expenditures to treat water coming from the burnt area. So it's definitely, again, taxpayer money. You're going to have clean water at the end, at the tap, but you will have to pay more for it. And so we're talking here for living lakes. So I want to just do a little bit of focus on lakes. I'm almost at the end of my 30 minutes, but I hope I can squeeze a few more slides. And we're pretty lucky in Canada because even though it's not a very, I guess, not the most active field of science in Canada, unfortunately, but we've been working on that for pretty much 40 years. So yes, the worries regarding wildfires and water security have been here for nearly 10 years or 15 years almost, I guess. But people in Canada have been working on wildfires and their impact on watersheds and rivers and lakes for nearly 45 years. And the first publication I was able to find for Canada was by David Schindler in 1980. He worked a lot on the experimental lake areas. Here on this map, you see those dark blue triangles are for those studies that look into the impact of wildfires on lakes. You have some in Quebec around the Grand Reservoir. You have some in the experimental lake area, and you have some in the boreal forest and boreal plain, both boreal plain and boreal shield. But when you look at the size of Canada, it's definitely not many studies. Over 45 years, it's, I don't know, something like 40 studies. It's definitely not much. You've been more for the past 4 years now. There are some more studies about on this topic, but still, given what I think, and I'm biased obviously, but what I think is a pretty major cause of concern and potential risk to public health and ecosystems, I wish there was, it was a more active field, because something we've really realized is that it's not only the fire that can impact the way a lake is going to work. There are many, many other aspects that are going to influence the way wildfire will impact the lake. For instance, the size of a watershed compared to the size of the lake. If you have a small lake with a pretty big watershed that has burned, you're going to have most likely very severe impacts. You're going to have also the type of vegetation that has burned, the topography of your watershed, the type, the hydrology of your lake. Is it mostly do you have a lot of influx from groundwater? Is it mostly fed by surface water? But something I wanted to talk about specifically about lakes is about the smoke. You have this paper that was published last month, and a few others that were released pretty recently that really show that smoke is really a real cause of concern nowadays, because the problem with smoke is that it's not limited to the watershed that is burning. It can go so much far away, and actually this is that can go, when it comes to smoke, it can go all around the globe, and we can start to see some imprint of this smoke, because it's going to get deposited on lakes, either deposited as wet, dry deposition, just like the smoke falling down naturally, and wet deposition is going to rain, and it's going to take a number of smoke, I guess compounds with it, and get onto the lake. So smoke has really become a huge source of concern. It's blocking sunlight, it's decreasing temperature, but it's also acting as, I was talking as fire as a huge sort of fertilizer. Smoke, that's what it does. It deposits a whole lot of nitrogen, especially it's going to boost primary productivity, and you might have so much more algae as well. Another source of concerns when it comes to smoke is mercury. Mercury, when it gets deposited at the surface of the lake, might be transformed into methyl mercury, and it's going to go accumulate through the food chain. And again, go back to some of you who might be anglers, you're going to fish that actually might have levels of mercury that is dangerous for your health. So again, sort of things that is important to keep in mind. From the same paper here, just to really I guess insist and really stress the importance of smoke and the concerns around smoke. You see in 2021, it's over 90% of North America that has experienced some level of smoke, and some places 150 days of smoke. So usually smoke only impacts a lake for a few days to a few weeks. But when you start to think about the same event happening year after year after year, what might be the long-term consequences of those high frequency smoke events? I don't know. I don't think anybody knows for now, but this is again the sort of concerns that people increasingly have for water bodies, especially lakes, and those lakes that are used for our water supply. So I guess I'll leave it at that. That's a lot. Could have gone like, could have provided much more, but I think that's enough for today. If you want to, just to read for yourself a number of other things, there are, I said the topic has exploded this past decade. You have more and more things you can find online. I really advise checking The Conversation, which is um, like it's I can describe that, like it's not really a newspaper, but like it's a platform where scientists write for a large audience. So you can really go, and like scientists are the main authors talking to you about science, but it's very accessible. Um, and yeah, like, so I will share, I can share this PowerPoint, no problem. And like, if you want to know, if you want to look at those resources, I have no problem. And I advise, if you want to know more generally about wildfires and like the sort of challenges that exist in Canada, I recommend checking Wildfire Facts from Canada Wildfire at the University of Alberta. And with that, thank you very much. Like, it's the product of like over a decade of work. Thank you very much again to Living Lakes Canada for the opportunity to talk about that, and thank you to the many organizations and people that have supported me throughout the years. And with that, thank you very much.
Wow, thank you so much, Francois. I mean, that's quite a task, synthesizing a PhD into a half-hour presentation. Yeah, that was just wonderful. Now we'd like to pass it over to our audience, and Victor rather, that will be sharing some of the questions that came up in the chat, and we'll try to get to all of them. If we happen to miss a few, then we will follow up with those questions that weren't able to be answered. But yeah, I'll pass it over to you, Victor.
All right, thanks, Camille, and thank you so much, François, for what an amazing presentation. So I have a question here. Current forestry management involves clearing the forest floor in order to prevent wildfires. How will that affect water storage, filtration, etc.?
Oh yeah, that's a very good question. Well, it's interesting. A review was recently published about that, and well, it will depend. That's really much the problem with a lot of those questions. Is it's going to depend the kind of forest first we're talking about. Like, are we talking about like clearing of deciduous or a coniferous forest? What kind of clearing are we talking about? Are we getting rid of everything for like to are we getting rid of it essentially all your understory? Are we getting rid of, like, are we pruning trees? Is it like, selective, or is it everything disappearing? So I guess it's pretty hard question to answer, but at the same time, there is a, usually when you have less vegetation, you're going to have less water demand because you just have, less vegetation growing. So what you can see to some extent is like you're going to see an increase in runoff and potentially an increase in stream flow. But again, like, it's up to some threshold. And some people in the US have been working on that because in the US, they have the same problem as in Canada. We have many forests are overstocked. Essentially, for the past century, we haven't had enough fires. So we have just too much forest with too much biomass, sucking out like way too much water. And there was a study released a few years ago that looked into the Yosemite National Park, where they cut part of the trees, just doing some field treatment, and they were able to reach, a certain level where they could increase the stream flow without, like impacting water quality. So again, it's going to depend what are your objectives, the kind of treatment that is done. Yeah, really it depends. I'm sorry, that's just the best answer I can give.
No
And
worries.
I can provide again, there was a recent review published. I can definitely share that with you, and they'll cover everything from around the globe.
Cool. So I think we just have enough time for one more question. Do we tend to see eutrophication and dead zones in the water after wildfires from all the nutrient runoff?
So it's one of the big questions nowadays. Like, yeah, like we have the concerns, like there is concerns about eutrophication because of like some level of enrichment. But the reality is that I've never seen anything published talking about eutrophication. I've heard about like some testimonies, some anecdotes of like some eutrophication, some like algal blooms leading to some level of eutrophication. But it's also going to depend on the kind of lakes, we're talking about. If it's we've seen in the scientific literature that if you already have a lake that is like already at this like eutrophic sort of like ecological level, you're not necessarily going to see a huge difference in like, in the productivity of your lake. But if you go to oligotrophic lakes, like, that don't have like much nutrients to start with, you might start to see more of this, like phytoplankton, like this growth of phytoplankton. But is it going to lead to eutrophic, like algal bloom eutrophications? So far, we don't really have much scientific evidence for that. We have scientific evidence in the ocean. Last year, there was a great publication showing that after the wildfires in Australia, it created a huge algal bloom, huge amount of biomass in the ocean because of iron deposition from smoke. But again, when it comes to the state of science right now, this question, we're still a long way away from knowing.